I'm Anil Kumar. Welcome to my video on sine law. We'll first derive the relation between sine of an angle with the sides and then take up two examples, one for finding the side lengths of a triangle and the other one to find angles in a triangle. So let us begin with a simple derivation for sine law. So let's consider any triangle ABC. So here is our triangle ABC. We'll drop a perpendicular from C to AB. So that's the altitude. So that's the perpendicular drawn from C to B. Let's call this point as D. Now, the side opposite to A will be referred to as A, side opposite to B will be referred to as B, and that opposite to C will be C. So what I'm trying to say here is that the length AB is C, lowercase. Now, let us say that AD, so let's say that height CD is H. Now what we will do here to derive sine law, relate sines of angle A with opposite and hypotenuse and also sine of angle B with opposite and hypotenuse, right, in these two triangles and get a relation. So let's consider triangle ACD. Now in this triangle ACD, what is sine A equal to? Sine A is H over B. So from here you can write B sine A is equal to H. Perfect. Okay. Now let us consider the other triangle. So which is triangle BCD. In this triangle, what is sine B equal to? Let's write down. Sine B is equal to H over A. So when you cross multiply, you get A sine B equals to H. Now what do you notice here? B sine A is equals to H, A sine B equals to H. That means we could relate these two equations, correct? These two H's are same. So looking into this, we can write B sine A is equal to A sine B. Since both are equal to H, perfect. Since both are equal to H, we could write this relation. And now what? We have a relation which relates sine with its sides, correct? So if I divide both sides by, let us say, AB, right? If I divide both these sides with AB, I divide this by A times B, this also by A times B, what do I get? Now this B and B cancel, and here A and A cancel. So what you see here is a relation between sine of an angle and its side, correct? So we could write this as sine A over A equals to sine B over B. Perfect. Now it could also be written as, you could flip it, A over sine A equals to B over sine B. Either way, we can use this law. Now we did this derivation using angle A and angle B. Now if you redo the whole exercise, and this time instead of dropping a perpendicular from C, let me show you another diagram. If I do the same calculations, but this time my altitude is not from C to AB, but let us say it is from A to CB, right? Let's say this becomes the height. And if you consider the triangle, angle C and angle B, what will you get? So this time we use these two triangles to get our derivation. Perfect. But instead, if you use C and B now, these two angles with perpendicular, it doesn't look like, but think it is a perpendicular. Is it okay? If this is at right angles, and if you use these two angles, then you can say that B over sine B will be equal to C over sine C. So that is how we can extend it. So here I'll extend it to sine B over B equals to sine C over C. Now to get that one, you have to again redo this calculation. Just find height in terms of sine of C and B and you'll get it. Perfect. So the relation which relates sine of an angle and its side in a triangle is called the sine law or the law of sines. Perfect. Now this law of sines could be applied to find side length or the angles in a triangle, provided we have one combination. So what we need here is one combination of opposite side, length and angle. So if you have that, that means you need either sine A over A or sine B over B or sine C over C, right? Either the angle and side, any combination, then you could do it. And the cases where we could solve a triangle using sine law are two sides are given to you and an angle, not the included angle. Or if we have two angles and a side, or if we have angle and two sides. So in these cases, you could apply sine law. So when can you apply it? When we are given two sides, let's write two sides, and an angle, and can also be applied if you are given two angles and a side to solve any triangle. Note, in this particular case, the angle is not included in angle, right? Not included angle. That is to say, we do not consider the case side angle side, right? Not included angle, but the other angle. Is that okay? So we'll take up examples to highlight this particular point. Now let's take up two examples, one to find side lengths and the other to find angles. But I hope this derivation for the law of sines or the sine law is absolutely clear. So let us first solve a triangle in which we are given two angles and any side, right? So basically we are given two angles and any side. In short, we could write as side angle angle or angle side angle. So what I mean by saying side angle angle or angle side angle, let's understand these terms also. So let me just sketch a triangle here. So when I say angle side angle, in that case I'll give you this angle, that angle, so angle and side in between. When I say angle side angle, right, and this side, then it becomes angle side angle. But if I give you two angles and a side, then it becomes side angle angle. So I hope that nomenclature is clear, right? So this is a triangle given to us, and let us say the sides are 50. Okay, let's say this is 50 degrees and the other one here is 40, let's say 8 degrees. Okay, so close by. And let's say this side is given to us and let's call this as 10 centimeters. we need to find the other sides. Now, whenever you're given two angles, you can always find the third angle. Perfect. So let's say the triangle here is PQR. So in that case, what is angle Q? So the angle Q will be 180 degrees, take away 50 degrees, take away 48 degrees. So we can use calculator. So we have 180 minus 50 minus 48, 82 degrees. So we get the third angle. So whenever two angles are given to you, you can always find the third angle. Not a problem. Therefore, we could write AAS also. It's one and the same thing, right? We could also write AAS. So any two angles and a side is given, we can solve the triangle. So how do we find the other sides? We use the sine law. If I need to find PQ, then I'll write it as PQ over the angle opposite to PQ, which is 48 degrees, which is sine of 48 degrees. Now that should be equated to the known combination. And this is a known combination. A combination of angle with opposite side length. So since we wrote side length on the top, we'll write the length 10 on the top divided by sine of 82. Perfect. So we get one equation to solve. From here, we know length PQ. You could also write length PQ as equal to 10 times the ratio of sine 48 degrees over sine of 82 degrees. Perfect. For the other side, we can do a very similar calculation. QR, the length QR over angle opposite is 50 degrees, sine of 50 degrees, should also be equal to 10 over sine of 82 degrees. Perfect. So QR is equal to 10 times sine of 50 degrees divided by sine of 82 degrees, right? Now we can use the calculator to find the answer. So the ratio basically is between the sines of the angles, right? So what we get here is 10 times sine of 48, and we are going to divide this by sine of 82. We'll round the answer to one decimal place. Okay, so we'll round this answer to one decimal place. We get 7.5. The units are centimeters. So PQ is 7.5 centimeters. Now let's find what QR is. 10 times sine of 50, and we divide this by sine of 82. So we get 7.7 centimeter. So this is 7.7 centimeter. Correct? So we'll note that since the angle 50 is slightly more than 48, the side is also slightly more than the side opposite to 48. So that is a good check that you have applied the formula perfectly. Is that clear to you? Right? So this is the sine law, which gives you the solution of a triangle where we are given two angles and any side. So we could find all the sides of this particular triangle. Now let us take up the next example where we'll see how to find angle using the law of sines or sine law. Now let us solve a triangle where two sides and an angle is given to us, and we'll find the angles of this triangle. So let me just sketch one triangle here. Let's say the triangle for us is kind of like this. So in this particular triangle, we are given two sides and an angle. So let's fix the angle first. Let's say this angle is given to us as, let's say 52 degrees. Now the sides which we are talking about, we should definitely have a side which is opposite to this angle. Now that's very critical, right? So one of them has to be side opposite to this angle. So let's say this side is 10 centimeters. The other side could be any one of these, right? So let's take the other side here as 12 centimeters. Does make sense to you? So we have two sides and an angle. We could also call this as angle side side. Important to note that the angle is not in between the two sides to use sine law. Perfect. That is kind of very important to understand. Now let's label this. Let's say this triangle is triangle ABC. And we want to find now which angle to start with. Since we know one combination, which is angle and opposite, we can apply the sine law, right? So we'll apply the sine law, the law of sines. Now, the other side is given to us as 12 centimeters, which is opposite to C. So it's a good idea to only start with C. Otherwise, you can get stuck. Now, this is very important to understand, correct? So we'll start with C. So we'll write sine of C over the side opposite, which is 12, should be equal to what is given, sine of 52 degrees over the side length of 10. So we can now cross multiply and say sine of C is equals to 12 over 10 times sine of 52 degrees, right? Just cross multiply. So you can use calculator to find this answer. 12 times sine of 52 degrees, and then we'll divide this by 10. Write the answer to at least 4 decimal places. Sine C equals to 0.9456. Do you see that? I wrote 4 decimal places for accuracy, right? So what is angle C? Sine inverse of this will be angle C. So we can find this as sine inverse of 0.9456. Now this number is already in the calculator, so I could do shift sine inverse of our answer, right, is equal to, so we get the angle C as 71.01. So that is angle C, which is 71 degrees, right? So we could write this as equal to 71 degrees. So we get angle C as 71 degrees. Now we can definitely find what angle B is, correct? So from here we know that angle B should be equal to 180 degrees minus 52, and what we calculated, 71 degrees. So that gives you 180 minus 52 minus 71, and that is 57 degrees. So do you see how we found the angles? When one angle was given and combination with opposite side. Now as an exercise, just to practice, you can also find CA. So let's review the concept. CA I will write on the top. So side length CA is over the angle B, which we just calculated as 57, sine of 57 degrees, is equal to what was given to us, the side length of 10 over sine of 52. So CA, the length, is equals to 10 times sine of 57 degrees divided by sine of 52 degrees. Let's calculate. So it is 10 times sine of 57 degrees divided by sine of 52 degrees, right? So it is 10.64. So rounding to one decimal place, we get this as 10.6 centimeters. Correct? So that is how we could actually solve our triangle completely. So I hope the steps are absolutely clear. So we started with the derivation of sine law, which could be written as sine A over A equals to sine B over B equals to sine C over C for any triangle ABC. Now this could be written in the reverse order also. What we also learned is good idea to always put the unknown on the top, right? So that cross multiplication directly gives you the answer. Whether that unknown is an angle to be found or the side, as we did here. So I hope you can concentrate here. This was unknown, this was unknown, right? We kept it on the left side top to make easier calculations. So if you follow these steps, you could efficiently answer most of the questions based on sine law. In the next part of the video, we'll take up some application questions to apply sine law and solve such questions. Thanks for your time and all the best.